All right, so chapter 6, our first section's on operations on functions. What we're going to do in this section for the first day is we are going to add, subtract, multiply, and divide functions. This is something that we have already learned in chapter 5 and 5.1, but the difference is in 6.1 we are going to introduce new notation to show you that. So here is what that looks like. Whoop, not f plus x. F plus g will be together in parentheses, and what that says is the function called f and the function called g will be added together, and the x out to the side, all that that's saying is that x is going to be the variable that they use in this function. Now when you're doing f plus g, all that you really have to worry about is adding your like terms. Now be careful when you're adding your like terms and watch your signs. That's one of the most common errors that I see. Just a reminder, I know that this is something that you guys have covered, and the majority of you guys do really well with exponents, but I still have some people that confuse when they're supposed to add the exponents together and when they're not supposed to add the exponents together. When we are adding two terms together, the exponents never get added together. That only happens when you're multiplying the terms together. And then finally, just remember your order of operations. When you are subtracting, that's going to look like this. And remember when we subtracted functions before, we put the second one completely in parentheses and then distributed the negative throughout. That way we didn't make careless sign errors. That's what we're going to do here as well. And the short version of saying put it in parentheses and distribute the negative is to just change every single sign in the second function. That only applies to the second function, so be sure that you're not changing all the signs in both. Once you've done that, you just simply need to add the like terms again. And like always, don't add your exponents and remember PEMDAS. Now, multiplication. Multiplication has the same kind of notation that we've used in addition and subtraction. And it's very important that you pay attention to the fact that it is a closed dot, because in day 2, when I get back on Tuesday, we will do something called compositions, and in which case it looks just like this, but it has an open dot instead, and that means a completely different operation. So a closed dot indicates that we multiply the two functions. Now I would prefer that you use the boxes to multiply. If you absolutely insist on just distributing, just be careful and make sure that you distribute every term in the first one to every term in the second one. But it is very easy to get lost in that. Now, since we are multiplying, you do add your exponents when you're multiplying. Once you're done multiplying in the box, you're going to add your like terms, and remember, as always, follow PEMDAS. For division, we do F over G, which indicates you're dividing these two. And I would say in most cases, we don't actually go through the process of doing box method to divide these. They simply want you to recognize that it is division here. Now, I will say that you want to make sure that it's simplified. So we'll look at what that looks like on the next page with some examples. But at this point in time, I'm not going to make you go through the box method to actually fully divide the polynomial. And when we are dividing these, you do want to list next to your answer anything that's going to make that denominator 0. Now this video will also be uploaded onto my YouTube channel, so you can go back and you can watch it on there as well if you for some reason don't get all the notes or it's going too fast or you want to hear it again. All right, so now let's take a look at some of these examples. Now you do have them on your packet. Unfortunately, I can't make this too much bigger than it already is, but you've got the same problems on your packet. So for number 1a, our f function is x plus 5 and our g function is x minus 4. So we're going to add these two functions. Be careful to line up your terms. And remember, we are not adding the exponents. We are just adding the actual term. So 1x plus 1x is 2x, and 5 minus 4 gives me positive 1. For subtraction, we have x plus 5 do pay close attention to the fact that f came first in this case. And we are subtracting x minus 4. Remember, our rule said that we are going to switch our signs. So this becomes minus plus. So I have x minus x, which goes away, and 5 plus 4, which becomes 9. Now we've got multiplication. And with multiplication, we're going to use our box. X plus 5 times x minus 4. X times x gives me x squared. Remember that we combine our exponents by adding. 5 times x gives me 5x. X times negative 4, negative 4x. And finally, 5 times negative 4 gives me negative 20. Now we're going to combine our like terms. So the answer that goes onto the blank would be just x squared. Negative 4 and 5, negative 4x plus 5x gives me 1x, and then negative 20. That's the answer that actually gets written onto your blank. Just as before, 2x plus 1 would be written on the blank, and 9 would be written on the blank. For division, we have x plus 5, and then x minus 4. I'm not actually going to make you go through polynomial division. You just have to set it up. Now let's take a look at this denominator. Remember that a denominator can never completely equal 0. When that happens, we have something that's called undefined. So we need to indicate not only x plus 5 over x minus 4 as my answer, but we also need to say that x cannot equal 4. Because when x is 4, the whole denominator becomes 0, and that would make it undefined. So the whole part that goes on the answer blank is x plus 5 over x minus 4, and then we need to indicate that x can't be negative or can't be positive 4. Let's take a look at the next one. For the next one, we have x squared is our f, and 4 minus x is our g. So when we add them together, we have x squared plus, there are no x squareds in the g of x term, or the g function, but there is a negative x, and there's a positive 4. So there's no regular x's in the f term, and there's no constant here. Just so that you're aware, we're lining up our like terms. We have x squared minus x plus 4. That's what it is when we add those two together. Subtraction looks very similar. X squared, we don't have any just x's, and we don't have any constants. And in the g function, we don't have any x squareds, but we have a negative x, and we have a positive 4. And since we are subtracting, that means that we are going to go through and change each sign in the second function. So I have x squared minus no x squareds, that's still x squared. 0x plus x gives me 1x. And 0 minus 4 gives me negative 4. Multiplication. Multiplication, we're going to set up our box. I'm going to move it over here so that I have a little bit more room. And we have x squared multiplied by 4 minus x, or you can write that as negative x plus 4. Same cup of tea. 4 times x squared gives me 4x squared, and x squared times negative x gives me negative x cubed. So combining like terms, there aren't any. My answer is just negative x cubed plus 4x squared. For division, our f function is x squared over my g function, 4 minus x, or you could write it again as negative x plus 4. And in this case, it's division, which means I have a denominator left over. So what can't x be? Meaning, what is going to make, if I put this in for x, it will make the whole denominator equal to 0. And that number is, again, positive 4. If I put 4 in as x, that would make the denominator 0, and in which case I wouldn't be able to have this. It would be undefined. So make sure you list both parts for division. Anytime you have a denominator, you need to list both parts. Now the next one might look just a little intimidating because they're giving you a fraction to start with, but we're going to work it out the same way. In this case, I have 3x squared, and I'm adding to it, I'll do it horizontally this time, 5 over x. Well, there are no like terms for me to combine. Therefore, this is my answer. Subtraction looks very similar. 3x squared minus 5 over x. Again, there's no like terms. And so we have our answer. Now with division or multiplication, you can again set up your box. This one's kind of nice because it just has one box. So if you were going to ever do distributed property, this one would be the one to do it with. Now these don't get their own separate boxes because they are still all one term. Remember, terms are separated by addition and subtraction signs. So this is all just one box times one box. Oops, let's change that to an x squared. There we go. So I have 3 times 5 gives me 15. And then I have this x on the bottom. So x squared times 1 over x, or an x on the bottom. Think of it this way, x squared over x. That simplifies down to just be an x. So I have 15x as my answer. Then division. Division gets a little tricky because I already have a fraction as one of my functions. So you can't just leave it like this. We don't allow for you to leave it as a complex fraction. That's what happens when you have a fraction in a fraction. We don't want to leave it like that. Instead, let's write it horizontally. 3x squared divided by 5 over x. Now, you should know that I can make that first term into a fraction as well. That first function into a fraction. And how do we divide fractions? You keep the first fraction the same, change it to multiplication, and flip the second fraction. So I have 3x squared times x gives me 3x cubed over 5. Now in this case, I don't need to list anything for what x can't be because x is not in the denominator. So x never has, or the denominator never has a chance to actually equal 0. So 3x squared cubed over 5 is my answer. I'd like to give you guys a chance to try this last one. So I'm going to ask the substitute to pause the video now, and I'm going to give you guys about a minute or two to run through an addition, subtraction, multiplication, and division. And then when you all are ready, when just about everybody's finished, you can unpause the video and I'll have the answers shown for you. All right, so that is all of day one's notes. On Tuesday, we will pick up with doing composition of functions. Have a great day.